Okay, today we're going to look at section 5.1. The very first part of 5.1 talks about the triangle mid-segment theorem. So it says if a segment joins the midpoints of two sides of a triangle, then the segment is parallel to the third side and is half of its length. So a mid-segment is just a line that's joining two midpoints on a triangle, the side of different sides. We're going to look at how we could prove this theorem using what's called a coordinate proof. So we're going to start by putting a triangle in a place that is convenient to us on the coordinate plane, which means we're going to let one of the vertices be at the origin 0, 0. That'll make our calculations easier. And then we're going to choose variables to use for the coordinates of those vertices. Alright, so here I've drawn in a triangle with O at the origin, 0, 0, and the top vertex is P, and then there's Q. So I've just assigned for Q to be at A, 0, and then P, we're going to call its coordinates BC. And then we have R and S, and I've joined those 2 points on the triangle, and this will be a mid-segment because it's given to us that R is the midpoint of not OP. Yes, R is the midpoint of OP, S is the midpoint of PQ. So that means that RS is a mid-segment. What we're trying to prove is that the line RS is parallel to the line OQ, and also that the length of RS is equal to 1/2 the length of OQ. So the first thing that we're going to do is we're going to use the midpoint formula to find the coordinates of R and S. So just in case you've forgotten the midpoint formula, it is the x1 plus x2, so the x coordinates added together and then divided by 2. That'll give you your new x coordinate. And for the y coordinate, you'll add the 2 y coordinates from the points and divide by 2. So for R, I'm looking at the points from O and P when I'm doing the x and y coordinates. So for O, the x coordinate is 0. For P, the x coordinate is B. So I'm just adding those, 0 plus B divided by 2. And then I add their y values, so 0 plus C divided by 2. So what I get is B over 2 and C over 2. Those are the coordinates of R. Then for S, I'm going to be using points P and Q. So I do the x coordinates added together, A plus B divided by 2, and then C plus 0 divided by 2. So that gives me, when I simplify, A plus B over 2 for the x coordinate of S, and C over 2 for the the y coordinate of S. Alright, so we needed these coordinates to be able to do anything else. The next thing that I'm going to do is to try to show that RS is parallel to OQ. So remember that parallel lines have equal slopes. So what I'm going to do is I'm going to try to find the slope of line RS and the slope of line OQ and make sure that they're the same. So one thing I could do is notice that the y values of R and S are the same value there. And also, if I looked at the y values of O and Q, those are also the same. So that kind of is going to tip me off that maybe I'm going to end up with the same thing for at least on top of the slope formula, because I'll be subtracting C over 2 minus C over 2, or 0 minus 0. So I just went ahead, and for M1, this was the slope of RS. Alright, and I did C over 2 minus C over 2 on top, and then I subtracted the x values, A plus B over 2 minus B over 2, in the denominator. On top, I got a 0. In the denominator, I could have made this all one fraction and had A plus B minus B over 2 since their denominators were the same. So that just left me with A over 2. That really didn't make any difference, though, at all, because the numerator was 0. So 0 divided by anything is 0. So that's the slope of RS. And then M2, I was calling that the slope of OQ. Well, I can't get this to write very well. Alright, so again, I subtracted the y values on top, 0 minus 0. In the denominator, I subtracted the x values, a minus 0, so I got 0 divided by a, which is 0. So their slopes were the same, which tells me that RS is congruent to OQ. I mean, not congruent, parallel. Alright, the other part we need to show is that RS is half the length of OQ. So in order to do that, we're going to need to use the distance formula. Alright, so we have to go to the next page. I didn't have room. Alright, so I went ahead and right here I wrote down what the coordinates of R, S, O, and Q were so that we could reference those since we had to change pages. The distance formula is given at the top in case you've forgotten it. So what I'm going to do is subtract their x coordinates and then square it, plus the difference of their y coordinates squared. So for RS, I'll be doing, let's see, a plus b over 2 minus b over 2, and then I'll square that, plus c over 2 minus c over 2 squared. Alright, and I'm going to take the square root to the end. So when I work this out, I'm going to get, in the first part, a plus b over 2 minus b over 2, that's the same as a plus b minus b all over 2 since they had a same denominator. And then the second part is 0 squared, or just 0. So this is going to end up giving me a over 2 squared plus 0. So if I take the square root of something that's squared, it just gets rid of that squared, and I'm left with a over 2. Okay, so if you had squared it underneath first and gotten a squared over 4, and then took the square root of top and bottom, you'd still get a over 2. Alright, for OQ, I'm using the coordinates given on the left-hand side over there, so I'm going to have a minus 0 squared plus 0 minus 0 squared. Alright, that's going to give me the square root of a squared plus 0. So just the square root of a squared, which is a. Now I'm asking myself, does RS, the length of that, equal 1/2 the length of OQ? So if I just put in what I got, I have a over 2 was what RS was. Looks like a 9. Is that equal to 1/2 times a, which is what I got for OQ? And the answer is yes. So I've proved my second point. Okay, so the coordinate proofs are not like the proofs we've done in the past. It's actually using things like the midpoint formula, the distance formula, slopes, and those kind of things that we can do on the coordinate plane. And so we'll be doing that sometimes as we go through this chapter. Alright, so let's look at example 1. Here's a picture that I've drawn like the one in your book. We have a triangle EFG, this is a larger blue triangle, and in that H, J, and K are midpoints. Clearly my picture's not drawn to scale, but just imagine that they look like midpoints. So what I'm supposed to be finding is HJ, JK, and FG. Now, remember that when there's not a line drawn over the top, that means I'm finding the length of that line segment. So our triangle midsegment theorem says that if there's a midsegment in a triangle, it's parallel to the side that it's across from, and it's half the length of the side that it's across from. So for HJ, I would be looking at the side that it's across from, which I know the length of, that's 100, and I know that it has to be half of that. So HJ will equal 1/2 times 100, which is 50. Alright, for JK, so I'm looking to see what side is it across from. JK is opposite the side EF, and that was marked as 60. So JK, the length of JK, is going to equal half of 60, which is 30. And then finally we're looking for FG. This time, this segment is not a mid-segment, it's actually part of the original triangle. So I'm seeing what mid-segment it's across from, which is HK, and FG has to be twice that. So we're thinking of it backwards. So this has to be twice HK. So that would be 2 times 40, which is 80. So if you know the mid-segment lengths, you can find the triangle lengths by doubling it. If you know the triangle lengths, you're going to divide it by 2 to get the mid-segment lengths. So pause and try quick check 1, where we have a given triangle that's got some things marked in it, and see if you can figure out what EB, BC, and AC are. Okay, so I hope you tried to find the answer before watching this. The triangle is marked so that I can see that from E to D and from A to E it's the same, which means E is a midpoint. And from A to B and B to C the lengths are the same, so B is a midpoint, which makes EB a midsegment. So they told me that from A to B was 10, and from C to D was 18. And they're asking me to find EB, BC, and AC. So EB is the midsegment itself that we have drawn in. All right, it's going to be equal to 1/2 of CD, or 1/2 of 18, because that's the side that is across or opposite it, the one it's parallel to. So the length of EB will be 9. Okay, BC is just the lower part of the triangle side, AC. So we had A to B was 10. If the way it's marked, I know that B to C also has to be 10, because it has to be equal to AB. And then they asked me the length of AC. So AC would just be the length of AB plus the length of BC. That's that segment addition postulate. So that's going to end up being 20. Okay, let's look at example 2. All right, example 2, we've got a triangle drawn in green, DEF, and they're telling me that A, B, and C are midpoints, and they're asking me just to name the pairs of parallel segments. So remember, according to the triangle midsegment theorem, if I have a midsegment in a triangle, it's parallel to the side that it's opposite. So if I'm looking at BC, it's going to be parallel to ED or DE. Now notice that I'm drawing a line above these because I'm not talking about the length now, I'm talking about the actual line segment itself. Alright, that's one pair. You can pause and see if you can figure out 2 more pairs before you check your answer. Okay, the other 2 pairs I would be looking at AC and EF. And the other midsegment is AB. It would be across from DF. So that's parallel. Okay, now try quick check 2. You're given a triangle, and they're asking you to find the measure of angle VUZ, which is here, and justify your answer. Okay, so if we look at the information in our diagram, we can see that U is a midpoint and that V is a midpoint because of the markings that are showing me the segments on each side are congruent. Alright, that means that the line UV, the midsegment, is parallel to xy by the triangle midsegment theorem. Alright, if those are parallel lines, then I could think of xz as a transversal. Okay, you would probably not be writing quite this much out if you were just trying to justify your answer, but I want to make sure you understand why. So I'm going to let xz be a transversal. That makes angle VUZ and angle X makes those be corresponding angles. Okay, so we know that corresponding angles are congruent, so that means that angle VUZ, the measure there must be 65 degrees. My pen is not writing right today. Okay. The last thing we're going to look at is just quick check 3. You can look over example 3 in your book. But here for quick check 3 we have this drawing. There's a lake and there's a bridge that goes over it from C to D. And they want me to find the length of the bridge using the drawing. So if I look at the information in the diagram, I can see that on either side of C, it's 963 feet for each of those segments. So that makes C as a midpoint. And then for D, they don't tell me the lengths, but they do show me with the markings that those are congruent. So C and D are midpoints, which makes CD a mid-segment. So what they're asking me is to find the length of the bridge from C to D. So it will be half the length of the side that's opposite it, which is labeled as 2,640 feet. So that's going to equal 1,320 feet. All right, that's part A. Part B asks, how long is the bridge in miles? So how would you figure that out? If the bridge is 1,320 feet, how do we figure out how much the length is in miles? Okay, we have to convert. So we remember that 1 mile is equal to 5,280 feet. So if I want to change that CD from feet to miles, I'm going to take how many feet I have, and I'm going to divide it by 5,280. Which will end up being about a quarter mile, or 0.25. I'm not sure how you do this in your physical science, but the way that I learned to do it was if I had 1,320 feet and I want to change it to miles, I'm going to multiply by a conversion factor, which ends up being written like division. But 1,320 feet, I would multiply it by using the conversion factor I have on top. But one's going to go in the numerator, one's going to go in the denominator. And I'm going to decide which one to put in the numerator by the units I want to end up with. So if I want to end up with miles, I'm going to put 1 mile on top. And in the denominator, I'll put the other part of the conversion factor, which is 5,280 feet. So what happens is my feet, the units feet, cancel out. And I'm left with the unit miles, but I did essentially divide 1,320 by 5,280. Okay, so do your assignment from the Google Docs, and I'll see you in class tomorrow.